Good afternoon, students. In the sequence of differential equation lecture, today we are going to continue the first order differential equation. Now, I am Dr. Govind Sharma, Assistant Professor, School of Applied Science, Suresh University, Jaipur. The objective of the lecture to know about the differential equation, and now we are going to start higher order of differential equation. Okay, and to understand the method to solve the higher order of differential equation. After this, higher order means that the in previous lecture I gave some few about higher order differential equation. In previous lectures, in 3 or 4 lectures, we discussed about linear form of quadratic differential equation and homogeneous differential equation, Bernoulli equation. So these exact equations, these are the type of first degree, first order differential equation. Now we go further for the higher order differential equation. So first, that's all the best. I am going to start and listen very carefully. It is very interesting and the base of differential equation. Okay, friends. Now I am going to start. Okay, friends. Let's start. Higher order, new topic. Higher order linear or differential equation. Differential. So the differential equation of higher order there, let the differential equation A0 A and minus. This type of differential equation called higher order differential. Here n is the order of derivative and A0 an minus 2 A0 are coefficient. And is the order of differential equation. That means n should be greater than 1. So if right there, this type of differential equation is called or higher order differential equation with with constant constant coefficient means constant coefficient means that a0 an minus 1 these are constant and coefficient of derivative, like for example 5 t2y dx plus 3 dy dx plus y is equal to. In this question, we see the order of differential equation is equal to 2 because d2 highest derivative is d2y dx. And, and 5, 3, 1 are coefficient. So, this equation is called higher order differential equation. With, with constant. Now, now we take a0 a1 dy upon dx plus a2y is equal to 0. This is a linear differential equation because the order of differential equation is reducing in each step. So and so this is second order linear differential equation with constant. Then the solution of this type equation solution of this type of differential equation. Zero this part of differential equation and this is another part of differential. The differential equation solution divide in two parts. Complete solution is CF plus CF. This part is provide us CF and this part provide us the CF means complete solution. Complementary function plus particular Okay, so students, the complete solution of differential equation, the higher order divided into parts. Complementary function plus particular integral. And we get CF from the left hand side and PI from right hand side. So for CF, we make the auxiliary equation and find the root of differential equation. So how we do it? First, first one complementary rule. Procedure to find let 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 differential equation a0 d2y dx2 plus a1 dy dx is equal to px. There we make auxiliary equation, we make auxiliary auxiliary differential equation. Replace dy upon dx. So auxiliary equation a0 m square plus a1 m plus a2. Okay. Now we find the root of auxiliary. फ्रेंड्स हम इसको सॉल्व करेंगे तो हमें दो रूट मिलेंगे. Let the root as the roots are the first. Now the CF, the value of CF or the expression of CF depend upon the root. So there are some cases for write the CF. First case first, when the root M1 and M2 are real and distinct. So the Y, the CF, CF हम राइट करेंगे C1 e की पावर M1x plus C2 e की पावर. ओके, जब डिफरेंट है तो और रियल है तो हम लिखेंगे C1 e की पावर M1x plus C2 e की पावर M2x. Now again case 2, when M1 is equal to C2. both roots की वैल्यू सेम है, then c1 plus c2 x e to power when the roots are complex or imaginary. Like alpha plus minus item. Then the see, c1 e to power alpha plus iota beta x plus c2 e to power alpha minus. Now here we can write e to power alpha e to power iota beta x plus c2 e to power alpha x e की अल्फा एक्स को कॉमन लिया और now हमारे पास c1 e की पावर आइटा बीटा है प्लस c2 e की पावर सिंपली हमने लिखा कि c1 e की पावर अल्फा प्लस आइटा बीटा एक्स प्लस c2 e की पावर अल्फा माइनस आइटा बीटा एक्स और फिर हमने e की अल्फा एक्स को अलग कर लिया और उसको कॉमन लेके बाहर निकाल लिया और ये अंदर बन गया हमारे पास c1 e की पावर आइटा बीटा एक्स प्लस c2 e की पावर माइनस आइटा बीटा एक्स नाउ c1 ये टर्म बन जाएगा हमारे पास cos बीटा एक्स प्लस आइटा एंड प्लस c2 इज इक्वल टू cos बीटा एक्स माइनस डिफरेंस। तो ये हमारे पास आ जाएगा ए की अल्फा एक्स c1 cos बीटा एक्स प्लस आइटा c1 sin बीटा एक्स प्लस c2 cos बीटा एक्स माइनस आइटा। जब हम इसको सॉल्व करेंगे तो अलग अलग करेंगे तो हम इसको मान लेते हैं e की पावर अल्फा एक्स c1 प्लस c2 को हम एक कांस्टेंट लेते हैं ए cos बीटा प्लस आइटा ये c2 है c1 माइनस c2 को हम लेते हैं बी ये कांस्टेंट टर्म में चला गया आइटा c1 माइनस आइटा c2 तो ये हमारे पास आ गया व्हेन द रूट्स आर कॉम्प्लेक्स। आई होप कि आपको समझ आ गया होगा रूट निकालना। एंड फोर्थ एंड लास्ट फोर्थ when the root of a when the roots are distant. Then, then हम क्या लिखते हैं e की power alpha x a और hyperbola under beta x plus b sin hyperbola under beta x distant. तो ये हमारा चार केस हैं. देयर आर फोर केस ऑफ सी है. तो इजीली हम निकाल सकते हैं. फर्स्ट केस है. सबसे पहला स्टेप क्या है, हमें जो गिवन डिफरेंशियल इक्वेशन है उसको ऑक्सिलरी फॉर्म में लिखना है. ऑक्सिलरी फॉर्म में लिखने के लिए हम क्या करेंगे कि डी वाई अपॉन डी एक्स को रिप्लेस कर देंगे एम से, तो हमें एम की वैल्यू मिल जाएंगे. तो हम रूट निकालेंगे एम. ठीक है. फिर उसके बाद वो रूट्स डिपेंड करेगा कि हमें डिफरेंशियल इक्वेशन किस फॉर्म में मिलेगी. There are four types of roots. First root is if the alpha and beta, sorry, m1 and m2 are real and distinct, then we get that CF is equal to y बराबर c1 e की power m1x plus c2 e की power m2. Second, if the roots are real but equal, then the equation write as y is equal to c1 plus c2 x e की power m. Third, when the roots are complex. Complex means alpha plus iota beta form. Then we write e की power alpha x e cos beta plus b sin beta. Actually, how we get it? We write the root real as per real c1 e की power alpha plus iota beta x plus c2 e की power alpha minus beta, iota beta x. And then segregate the e की alpha x. We can take common and we find c1 e की power iota beta x plus c2 e की power minus iota beta x. And e की power iota beta x we can write cos beta x plus iota sin beta x. So segregate the terms, arrange the terms, and we find a cos beta x plus b sin beta. Now, when the root are radical sign, then we get cos hyperbole or sin hyperbole. Now I take the example for CF. Well, d2y dx2 minus 9 sorry, d2y dx2 minus d2y dx plus 26 dy dx minus 24 y. Here an example to find the CF. D cube y upon dx2 minus 9 d2y dx2 plus 226 dy dx minus 24y is equal to 0. This is the linear form of differential equation, and and the order is 3. Not order, differential. But we have follow the same procedure. We take auxiliary equation. root of m is equal to you put 2. So at is equal to 2 रख के देखते हैं into the factor is 0.8 minus 8 plus 52. 66 is equal to 0. So m minus 2 is a factor. Now now we find another root here here 7 and 14 plus 12 is equal to 0. So we can write m minus 2 m square minus 7m plus 12. Or here we find m square minus 4m minus 3m plus 12. So m minus 3. These are the factor of equation, auxiliary equation, and we get 2, 3, 4. These are the root of differential equation. Okay. Now we see the case 2, 3, 4 are real numbers and are all are different. So the case first, I will take you on case first. The first case, when the roots m1 and m2 are real and distinct. So the CF is equal to C1 e की power m1x plus C2 e की power m2. और यहाँ तो 3 रूट्स है तो C3 e की power m3x. So CF is equal to C1 e की power 12, sorry, C1 e की power m1x, C2 e की power m2x plus C3 e की power C1 e की power m1 is equal to 2, m2 is equal to 3. ये आपका ओके. आप एक बार वापस इसको देखिए क्वेश्चन को. हमें करना क्या है, ऑक्सिलरी इक्वेशन बनानी है. ऑक्सिलरी इक्वेशन बना के उसके अंदर रूट निकालने हैं. रूट निकालने के बाद हमें पता लगेगा कि रूट रियल है या कॉम्प्लेक्स है या रेडियल साइन है या रियल है और सेम है. उसके अकॉर्डिंगली हमारे पास 4 केस हैं. चारों को अप्लाई करके हम सी एफ की वैल्यू. ओके स्टूडेंट, नाउ दिस इज अ वेरी सिंपल एग्जांपल ऑफ सी एफ. फाइंड आउट सी एफ. नाउ we take another example. plus 2p divided dx plus p square plus q square. Okay. So first we write the auxiliary equation. Auxiliary equation means we dy upon dx we write m. So now the auxiliary auxiliary equation is m square 2pm plus q square plus q is equal to 0. And now this is the quadratic equation. So we find m by the formula root formula minus 2p. B square 4p square for AC p square plus q square 2. So minus 2p plus minus 4p square minus 4p square minus 4. Here minus p square plus p square cancel minus 2p plus minus iota 2q upon q है compulsory p plus minus 2 common cut by 2 so cancel this becomes minus p plus minus. Now this is the form of alpha plus minus imaginary form. So now we can write here y is equal to e to power alpha x is here y. A y is equal to here y is equal to e to power alpha x a cos beta x plus b sin beta x. So here alpha is equal to minus p and beta is equal to q. So we can write e to power minus 3x a cos x plus sin. This is our question. Here we find we have done two examples for find here. Okay, for here we have here the important part to find out the root of auxiliary equation and then write the CF equation. Okay, I hope कि आपको क्लियर हुआ होगा CF निकालना. Now I write some question for practicing you. This is helpful for you to do the practice of CF. So you should try on yourself. D2x plus here and here. Okay, minus uh, this is the half part of differential equation solution. So after we complete CF, we will go for PI. And after find PI, we add CF plus PI which equal to the complete solution of differential equation. So there is some clue for you that in first question, the auxiliary equation becomes 2n cos alpha m plus n square is equal to 0. So this will be the m minus 2n cos alpha plus minus root b square b is for n cos alpha square minus for AC. Okay, or upon. So this is the, I think this is, we get complex part. Complex, yeah, imaginary roots. So we apply the complex root e to power alpha x, a cos beta x plus b sin beta x. This is the CF. Here again in this question, auxiliary equation is, so one root is m is equal to 0 is the one root, and two roots we get from this quadratic equation. Third question, question number 5, we get n cube minus n square plus 4n minus 4 is equal. Here we get m three values, m1, m2, and according to the three values, we write the root of equation, and after find the root, we write PF part of the equation. Now friend, I hope after this lecture, this is very easy part of differential equation and easily you can understand to find the PF solution. Okay, in next lecture, we go through the PI. So now the time for a small quiz. Here some questions are there. A higher order differential equation is a relation between y and x, relationship between dy dx, y and x, and higher order derivative higher than 1. Absolutely, the third is 1, the higher order is derivative order higher than 1. If the order is 1, then this convert in the first order differential equation. Okay. Second, order of differential equation. Again, higher order to depend variable, highest order to independent, or highest order to derivative. I already this question asked to you in first order of differential equation, but here is also important because there we discuss about higher order differential equation. CF is a part of a solution of differential equation. CF means what is the CF? Complete factor, complementary function, complete function, and not. I think this is the B is the absolutely right question. Complementary function. Here, find the CF of a differential equation which m is equal to 1 and 1. The both m are real. Okay, both m are real and same. So the solution C1 plus C2x is equal to CF is equal to C1 plus C2x e to power mx. So m is equal to 1 here. So C1 plus C2x and e to power x. Write the complete solution of differential equation. Complete solution, I told you, complete solution is equal to CF plus CF. So these are the content for differential equation, higher order linear differential equation. Next lecture we will discuss about the PI. Students, thank you very much. This is very helpful for you because after this lecture, all differential equation solution we write in the form of CA plus PI. So this is essential to understand how to find the CA.